All right, guys, I'm going to go over the practice quiz. So, starting off with question number one, this is all about the cross sections. If you are making a cross section that's parallel to the base, that means it's parallel to the bottom, right? So that means that if I look at, let's say, cross sections of a cylinder, okay? Oops, actually, I meant to that. Okay, cross sections of a cylinder. If I cut across the shape like this, like let's say that's my knife that's going across, then that's a cut that's parallel to the shape. Okay. Whereas if I cut the cylinder like this right here, that's perpendicular to the base. And you can see the shape that's created there is a rectangle. So again, parallel to the base is cut across, and then perpendicular is cutting straight down. So if I'm cutting a straight across for this one, then that means it's going to create sorry, here, it's doing that. It's going to create a triangle. So that would be a triangle. All right, if I cut perpendicular straight down and look at it from the side, for this shape it'll also be a triangle. Okay. Now for this one, if I cut straight across, the bottom basically, what if you cut across parallel to the base, your cross section should look like the base. Okay, and if I cut straight across this one, I'm going to get a circle. Now the thing is with a cone, let's take a look at a cone here. Depending on where you cut the cone, you're going to have different size cross sections. So let's say for this one, for instance, you can see here on the top, if I cut on the top, I get a little circle. If I cut in the middle, I get kind of a medium-sized circle. If I cut really close to the base, then I'm going to get a circle that's just about the same size as the base. Okay, so that's why you see these options in here that say smaller circle or congruent circle. So if I cut somewhere in the middle here, that's going to be a smaller circle that's smaller to the base. So that's why the answer would be smaller. Whereas if I cut, like, let's say a cylinder, let me go back to this one. Let's say a cylinder, right? Well, that cross section is going to be the exact same size as the base, radius and all. So that would be a congruent circle that would be equal to its base. Okay. And the same thing with this. Let's see, how many sides is this guy? This is 8 sides, so octagon. All right. So again, if you do to the base, you're going to end up with an octagon. If you do a perpendicular, you can see from the side of that, it's going to be more of like a rectangle. Okay, so then on this one, what you're doing is you're rotating this object around the axis. In this case, you're rotating around the y-axis. And then on this one, you're rotating the same object around the x-axis. To kind of demonstrate this, hopefully this video can help kind of illustrate what this is talking about. Again, this is from the notes that we did before. Um, what they're going to do here is they're going to kind of color in and fill in the shape. And then they're going to start rotating this around the y-axis. So watch this. So as now they're going to pull the slider and see how it's starting to rotate all the way around the axis, and now it creates a new shape as that shape was rotated. That's what's happening with these little rectangles. Okay, so if I'm looking at that rectangle rotating around the axis, and let's say those are my axes, right? And here's the rectangle. That means that each of these points on the corners of that rectangle, I'm going to go around the axis, the y-axis, go behind it, and then back to where it started. And then it's also going to do the same thing here. It's going to rotate around and then come back to where it started. And now if I connect all that together, I basically end up with a cylinder. Now let's say that I do the same thing right here. But now I'm going to rotate not around the y-axis, but around the x-axis. So now I kind of come down, go under, come back here, do the same thing there. That goes around and back up. And now if I draw this shape out, and I'm drawing it kind of sideways here, that's basically another cylinder. If I turn it this way, it's a short, flat cylinder, okay? Instead of a long, tall cylinder. Okay, another example would be, what if that you rotate it around the axis while it's not attached to the axis? What I mean by that is, let's say that here's the axis and it's right here. So there's the object, and I'm going to rotate it around the y again, except this time the last one was right up against it, this one's not. So now I'm rotating it around. I rotate that point, I rotate that point, and then do the same thing here. And now what you're going to notice, if I redraw this, is it's basically another cylinder, but now it's got a hole in the middle. And it kind of looks like toilet paper, right? You know how you have like a little hole in the middle? So basically now I created a cylinder that has a hole. It'd be the same thing as if I had an object that's off the line and I rotate it around the x-axis. I go around, I go around, I go around, and now what that would create is a flat, kind of a short flat cylinder again, except this time there's a hole in the middle. Okay, it kind of looks like a tire. So again, that's what's happening with these shapes is we're rotating them around the axis, and you have to answer what shape does that create. So this one right here is right up on the y-axis. So that would pretty much be like that first one that we did, where it was right on the axis like this. So that made a nice, long, tall, solid cylinder with no hole in it. Okay, so that's how you'd answer that question. Okay. All right. So now number 3. Now what you're doing is you have some composite solids, in other words, different 3D shapes combined together. So the top of this tower would be the example of a cone. The bottom, just the longer part, that's a cylinder. Okay, these are examples of shapes with 1, 2, 3, 4, 5, 6 sides. So that means it's a hexagon, and they're hexagonal and they're rectangular around the outside. So that means they're prisms. So hexagonal prisms. The top right here is a triangle, but it's a square type triangle, so that's also a prism. It's a triangular prism. And on the bottom is another prism, but it's a rectangular prism. Sorry, not pyramid, but prism. Okay, and then this is a pyramid. Okay, but the way you describe it is based on the base. So if the base is a triangle, then it's a triangular pyramid. Okay, so now number 4. Okay, so what you're doing is just matching the shapes with the name. Again, if it has a rectangular side, that means it's a prism. And I count 1, 2, 3, 4, 5 sides on the top, so that means it's a pentagon. All right, now if you're looking at that one, that's a sphere. There's another prism. I'm sorry, not a prism, but it's a triangular shape, so it's a pyramid. And the bottom is a triangle, so a triangular pyramid. As you guys know, that one's a cone. That one's another pyramid because it has that triangular shape, but the bottom is a rectangle, so it's a rectangular pyramid. That one's a cylinder. That one's very similar to this because it's triangular. However, you can see that this side is rectangular. So if all the sides are triangular, it's a pyramid. But if any of the sides, like this one, are triangular, then it's a prism. And you can see that, or sorry, if any of the sides are like rectangular, like this one that you see in the front, then that is a triangular prism. And then that's a half a sphere, so which is hemisphere, stands for half a sphere. Okay, so now what you're supposed to do is find the volume of this shape. So I'm going to draw this thing out real quick. Oops. So over here you can see that, it's got a rectangular base and it has a height of 9. And when you find the volume of any type of triangular or pyramid shape, okay, or any of these pyramids, volume is equal to 1/3 times big B, which it does stand for base, but specifically what that means is area of the base. So big B is area of the base. Okay, so every base is a little bit different with each shape. So you have to find the area and then multiply that times 1/3 and its height. So 1/3 times base times height. Okay, so the first thing we're going to focus on is the area of the base. Okay, and to find the area of the base, if it's a rectangle, that means it's just length times width, 10 times 4. So the area of the base is just 10 times 4. Okay, and then times its height, which is 9, and multiply all that out. Let's see, 1/3 times 9, that's 3. 3 times 10 times 4 is 40, so 120. So it's 120, and this was meters. And remember, when we write meters, we always do cubed, so meters or cubic meters. Okay, so that should help you answer those questions. And you'll notice that in that question, that it asked you first what is the formula, and you can see since it's a pyramid, you would select the 1/3 base times height. Not this one. That's for rectangular prism type shapes. Okay, so then this one, it's asking what is the area of the base. Remember, that's the big B. So you can see it's m squared because it's talking about area, not volume. And that is 10 times that 4. Okay, basically this part of the equation, the 10 times 4, that's the area, right? So that's 40. That's how you answer that part. And then the height, that's given, that's right there. And then the total volume is 120 once I figure it all out. Okay, so the next shape is a cone, and it's upside down cone. Now with the cone, it's the same thing. Okay, it's the same, it's just like the pyramid in that the volume is 1/3 times the area of the base times its height. Okay, now the area of the base, or this base, is a circle. So now we have to remember, what is the area of a circle? Okay, well that's going to be, I'll write that off to the side here. The area of a circle is pi times r squared. So in the formula, I've got to calculate that. So pi times r squared. Okay, well remember the radius is going to be half of this distance here. So that's the radius is actually 12. So 12 squared. So 12 squared is 144. 144 pi. That's going to be your area of the base. Okay, so I can put that in here. And then times its height. Well, the height is the distance from the point of the cone to the bottom of the cone. And all I got to do is flip this thing if this is kind of confusing because it's upside down. But basically, I'm looking for this height right there. Now, I know that the radius is 12 because that's 24 all the way across. And I know that the slant or the side length is 26.8. What I don't know is what that height is, and that's the last part I need for the formula. So to figure that out, I'm going to have to use another formula to figure that out. And I want you guys to notice that created a little triangle right there. So it's a triangle like this, where the bottom is 12, the side, or hypotenuse, is 26.8, and we're looking for that side right there. Well, that's going to be a squared plus b squared equals c squared, Pythagorean theorem. Okay, so that side could be a or b, so I'll make that a. That's my b, 12 squared. And then the hypotenuse is always your c, so 26.8 squared. Okay, so now I'm going to subtract the 12 squared from both sides. I'm not going to figure out what 12 squared is yet. I'm actually going to go ahead and not really calculate anything yet. So now I get 26.8 minus 12 squared. Remember, the last step to solve these is to square root both sides. So I'm actually going to square root all of this and use Desmos to help me figure out what that answer is. Now you guys, you can do this on the calculator that's in class. I don't have that in front of me right now, so I'm using this. But I'm basically doing the square root of 26.8 squared minus 12 squared. Okay, you can see that the answer is 23.96. I'm going to go to the nearest hundredth because I'm actually not done yet. Remember, that's only just the height of the cone, so 23.96. So now that is the side of that triangle there. which is now our height that we were looking for, which now I'm going to plug into our formula. Okay, so that was what we were missing. So first, again, just to review, we had to find the area of the base, which was the circle, so pi r squared. And then we had to find the height, which was missing, by using Pythagorean theorem of the slant, or the side here, and the radius, which ends up being 12. Okay, so now I got to go and calculate this. Go ahead and use this on Desmos. 1/3 times 144 pi, and then times 23.96. So the final volume ends up being 3,613, and we'll go ahead and round to the nearest. I think it actually tells us where to round it to. It says round to the nearest hundredth. Okay, so we need two numbers after the decimal. So we want 0.08. That 2 does not affect the 8, so it's just going to be 0.08. So now our final answer would end up being that. Okay, so by the way, what you're going to end up doing on Schoology when you take this test is you're actually going to show your steps on Schoology. So what do I want is I'd want you to show some of these steps. Okay, probably I want to see you solving a squared plus b squared and then setting up the formula. You don't have to show every single one of these. That'd be a lot. Okay, so you could do, okay, I'm looking for the height, a squared plus 12 squared. Again, you don't have to like show the formula that with the letters. You just show what numbers you were plugging in, basically. 26.8 squared. Okay, that would be the first step. And then after that, I'm going to skip ahead and not show like all these steps. I'm going to just show this last step here, the a squared. A squared equals the square root 26.8 squared minus 12 squared, and I'm going to show that was, let me show the square root of the a squared as well. Okay, so again, I'm not showing every step, and I'm going to show that was equal to 23.96, which was the height. Okay, and now I'm going to plug that all into the formula, and I'm going to show this step right here where we set up the formula. Okay, you can show me that you could actually plug this in there, like the pi 12r 12 squared. So you could do like this: volume equals capital V. Capital V equals 1/3, and then in parentheses, let's see, pi. I guess I just like pi times 12 squared. That was the area of the base. Okay, and then lastly, times the height, the one that we found. And then you can show what that's equal to, 3,616.08. And this was in units of centimeters, so we'd say centimeters cubed. Okay, so that's kind of what I would expect when you guys actually do that. I don't expect you to show every single step, okay, but I want to see steps kind of laid out, so that the main ones, okay? All right, so then this one is a little bit more of the same stuff. You're finding the volume. It's asking if these are true or false. So remember, with this shape, this is a triangular pyramid, and the pyramids and cones use that 1/3 formula like this one, and the problem we showed before. So this is actually false. That would be a false answer, because we don't. This is for the rectangle, so that would actually be for this shape here. Okay, the base area is 8. Well, the base is a square, which means I multiplied both sides, 8 times 8. So the area would actually be 64. So no, it's not 8. So that's also false. The height is 7.2. Well, the side of it is 7.2, but the height, remember, is how tall it is going straight down to the middle. So this is not the height. So that would be false. Okay, so you're kind of just using the clues. Now this is a rectangular prism, and this the area, the volume of that shape is the area of the base times the height. There's no 1/3 there. Okay, so it says a possible base area could be 45. Well, basically, with the base, what that means, I should probably draw this one out and show what that means, because this is a possible base area, so that might be a little confusing. Like, what does that mean? So I'm just kind of drawing this shape out. Okay, we got 7, 5, and 9. Okay, so they're all in meters, and because it's a rectangular prism, I can pretty much use any of the sides. There's a total of 6 sides to this prism if you rotate this thing all around. Any of those sides in a rectangular prism could be a base. Okay. So, like, for instance, this side right here, that one is 7 by 9. Okay. So that could be a base. I could also use the one that's kind of on the bottom here, the smaller one, which is 7 by 5. Okay. And then there's another one here on the side right here, this one. And the length of that is 9, and then the width is 5. So there's like multiple sides in a rectangle that could be your base. So 9 times 7 is 63. 5 times 7 is 35. So these could all be possible bases. And then 9 times 5 is 45, which is what it was asking for. Is it could 45 be a possible base? And the answer is yes. Okay, so basically, is there a combination of these two numbers? If I multiply them, where do they equal that? Because when I actually calculate the volume, all I'm doing is that all 3 sides multiply times each other. So to get the volume of this shape, it's 9 times 7 times 5. It's just all of them. And it doesn't matter what order you go in. Okay, so any of those could be bases, and that's why 45 could be one of the bases, so that would be true. Okay, now the cylinder is very similar to the rectangle in that the cross section is a rectangular in shape. So the volume of this guy is also volume equals base times height, or the bare area of the base. The area of the base is a circle, so we're going to use that pi r squared again. So you can see it's 11 and 8 on the side. So 11 here, 8 all the way across, which means then that the radius is actually 4. So if I'm calculating the area of the base, that's going to be pi times r squared. So r is 4 squared, so 16 pi. So I'm just going to plug that into the formula. So now 16 pi times the height, which is 11, and that's going to give me the total volume. Okay, so now if I go over to the calculator, let's see what that looks like. It's going to be 16 times 11, and don't forget the pi. Okay, so you can see that it's 552.92. So that, let's see what it said. Okay, the radius is 8. That's false because the radius is half of the 8. And then the volume is 176 pi. Okay, now notice it showed it with pi. So I'm actually not going to calculate. Let's do this. So I'm not going to calculate the pi part. I'm just going to leave the pi, it's there. So what that basically means is I'm only going to multiply the 16 and the 11 and then leave the pi here. Okay, because sometimes you can calculate it without multiplying the pi. Okay, so I need to figure out what is 16 times 11. And it is 176. So then the answer would end up being 176 pi. Okay, and I think the units, what were the units here? They were centimeters, so it basically would be centimeters squared or cubed. So that is correct. Okay, because if I only multiply the numbers and not the pi, it is 176. So that is true. Okay, all right, so now number 8. All right, you guys remember these equations? These are the rational, or not the exponential equations. So where I have to figure out make them the same base. Okay, so here I know that if I bring out the powers chart, and you guys have these, you have these charts in class and you can't Google them, but basically I need to figure out what kind of power can I change these numbers into, this 216 and 36, to where they have the same base. I look around here, 36 can be turned into 6 squared. 216 can be turned into 6 cubed. So I'm going to use power of 6. So for 216, it's 6 cubed. And what I do is I bring down the exponent and multiply that or distribute it. And then for the 36, that's going to be 6 squared. And then I multiply that times negative 3b. Now remember, once you get the bases the same, they basically just cancel out. And I bring down the exponents. And now I solve. So distribute that first. That's 3b plus 6. Multiply those two. I get negative 6b. I got to get b by itself. So what I'm going to do is actually subtract the 3b from both sides. Okay, so now I have 6 equals negative 6 minus 3, which is negative 9b. And then the last step here is divide by negative 9. And if I reduce this, which I can use on Desmos to reduce it, divide those both by 3, then I would get 2 over 3, or negative 2 over 3. So then b equals negative 2 over 3. Okay? So I just had to make them the same base, just like we did well a week before. Okay, and again, this is another one where you're going to basically show the steps. So I would show, okay, 6 to the third power, and then b plus 2. This is a little easier to show the steps on this one. 6 to the second power times negative 3b. And then the next step I had on there was canceling the exponents. So then it was 3 plus 2 equals. Basically, you're just typing all these out. Okay. Next step, I can move this thing out of the way. By the way, if it's like kind of getting in your way, just kind of drag it and click it to set it somewhere else. Okay, so now I want to write 3b, and you don't have to like, you know how I'm like, subtracting 3 from both sides. I don't have to show that. I just kind of have to show what the line looks like. So then it goes negative b, and then the next step is 6 equals negative 9b, and then my final answer is b equals negative 2 over 3. Oops. Negative 2 over 3. Okay. So you can see I'm not showing every little detail. I'm just showing kind of the essential what each line would look like. Okay. And then the last one here, remember you're just switching the form. So if this starts out as a radical, I'm moving these into the exponent. So basically the 9 becomes the base. And then the 3, whatever that number is on the outside, the index, that becomes your denominator in the fraction of your exponent. And then the exponent inside becomes the top. And then the same thing here, going the other way. So now the 4 goes inside. The denominator is the number on the outside, the index, and then the numerator is the number that goes on the exponent. Okay, same thing here. Here, we're actually going to simplify this. Okay, so what we're going to do is we're actually going to distribute this 4 to the 3 and distribute this 4 to the 7 over 2. So let me show you how to do that. Okay, so basically I'm distributing that 4 to each number here. So then that would be 3rd to the 4th now. And then x to the 7.5 times 4. We multiply those exponents. So 3rd to the 4th power, again, I can just calculate that, or if you look on the powers chart here, 3rd to the 4th power equals 81. Okay, and then I have to multiply this fraction with this 4. So 7 over 2 times 4, and we kind of pull this to the side. Remember, I multiply the numerators. 7 times 4 is 28. And then divide by 2. That equals 14. So now the exponent all over the x is 14. So it's x to the 14. So then I would choose down here, you see 81. And then 14 is the final exponent. Okay. All right. That's the review.